Hello everyone and welcome to this new video in which we will talk about transform orientation. So we have already seen that it was possible to change Gizmo's axis orientation in this menu. If we orient the axis globally, the Gizmo is perfectly aligned with axes of the world. We can also align axes on the view. And there, the plane formed by X and Y axes of the Gizmo are always parallel to the view, no matter how the view is oriented. And the Z-axis becomes invisible since it is perfectly perpendicular to the view. Okay, so now let's discover another type of orientation. In orientation menu, we have several other choices: local, normal, gimbal, and cursor. We don't know what normals are yet, so we'll talk about this choice later, but it's very useful. Gimbal, as its name suggests, works like this kind of things, like a gyroscope. It can be useful, but I don't know if we will talk about it in this videos because its use is very specific. Cursor allows us to create a custom orientation using the 3D cursor, but for the moment, we don't want to do that. So let's choose local orientation. Well, not much is happening. But if we rotate our cube a little, look closely, I'm going to release the mouse and presto, we can see that the Gizmo has also rotated. And so the Gizmo stays aligned with our object. To show you the difference, we will go back to global orientation. For that we have a small shortcut. It's the question mark key. It opens a radial menu, and we have all the types of orientation with a small number. So to switch to global orientation mode, I press the 4 key or the button as desired, and we remember that to switch to local orientation we can press the question mark key then the 6 key. So here, we are again in global orientation, and there, as we have seen so far, the Gizmo has remained aligned with the world. Okay, so what is the advantage of using the local orientation? Let's imagine this cube is a car. So I'm going to cancel the rotation. We deform the cube a little with a scale. We scale it along y-axis with SY. Then I duplicate the object with Shift plus D. Let's put it here. A small scale on Y. And here we have our car. We will do as we did in the previous tutorial. We will link this object to this object so that I will only need to move the parent object. So I select the child object and the parent object, which becomes the active element. Control P, object keep transform, and so here we have our car, which we can move along axis. Now we're going to turn it a bit. Cars have steering wheels to be able to turn. So let's do it like this. And now how to make it move straight ahead this new direction. In global orientation, I have no axis aligned with the car, so I have to use 2 axes at the same time to do zigzags as if I were tacking on a sailboat. I can also use the XY plane, but it's not at all precise. The car could slide a bit like it's rolling on ice, because I don't have anything to maintain the car in the direction of the movement. To solve that, let's switch to local orientation, and there, one of the 3 axes. So here the y-axis is aligned with the car, and therefore I can make my car go straight ahead. It is also very practical when doing rotations. Let's create a new use case. So we're going to delete all that, and we're going to create, for example, a laptop. So for the base, I create a small cube, then I scale it along Z. I duplicate it to make the screen. I move it along Z and place it over the base. Now I will move the origin of the screen to the hinge, so it will rotate around the hinge. So for that we can do as we have done so far. We go to Option, and we check Transform Affect Only Origins. So let's move the origin, but it's going to be more practical to use an orthographic projection and a side view to move the origin precisely at the hinge. I don't forget to uncheck the option, and I'm going to link the screen to the base of the computer. So as before, we select the two objects in the correct order, Control P and choose Object Keep Transform. Here is our laptop. I go back to Global Orientation, and I can open and close it. So let's say now that we want the computer to be rotated like this, about 45 degrees. Now if we want to open and close the screen, well, we're super annoyed, because like earlier we're going to have to use two axes at the same time. It's not going to be easy, all for a result which will be far from perfect. What we can possibly do is try to align the view on the side of the computer, more or less like that, and there we can make a rotation aligned with the view. It's already more practical, but even if it looks like, I think it's not aligned perfectly. Plus, it takes us a long time to align the view to an object oriented with any angle. So, as before, I switch to local orientation, and now the x-axis is aligned with the computer. This allows me to make perfectly aligned rotation. It's awesome! Another example with a scale transformation. For this example, I'm going to open the bolter project that we modeled in the interlude. If you followed this tutorial, you may remember that we wanted to deform the magazine, and for that, I told you to first straighten it. Why? Because therefore the object is aligned on global axis, so we could use global axis to change its width with a scale along x-axis, and change its height with a scale along z-axis. If I had wanted to make these deformations after turning the magazine, so not aligned with axis, it would have given us this. If I scale along x in order to change the width, the height is also changing. The object is deformed on two directions at the same time, because the object is not aligned with the global axis, so x-axis also influences the height of the object. But if we think otherwise, we can say that it is not the object that is misaligned on the axis, it is the axes that are misaligned on the object. So I switch to local orientation, and there the axes follow the orientation of the object. So I can change the width with a scale along x. We can see that the red arrow is in the right direction, and we guess that it's going to be perfect. You can do the same thing with the height. I can fine-tune the height with the z-axis, and the deformation is only in the direction I want. If you have followed the bolter tutorial, you can see that local orientation is really life-changing. To conclude, I will explain to you why we use the local orientation a lot when we pose a character. For that, we will open the file of the video about parent links with our arm structure. For example, if I want to flex the arm, we know that an arm cannot bend in all directions. Otherwise, it means that you have broken your elbow. It should hurt very badly. In local orientation, I will be able to identify the axis that will bend the arm correctly, i.e. by playing on the angle that we already have here between the upper arm and the forearm. So here the z-axis. We will rather use the elbow, and here is the arm bends in a completely logical way according to the skeleton. For the fingers, it is exactly the same thing. With fingers, I have the right to do this type of rotation, and this type of rotation. On the other hand, this one is absolutely impossible. So if we were using global mode to do the rotation with consistency, like for the example of the laptop, we would have to play with different axes. Whereas if we use local axis, there we can bend fingers with consistency. Well, I think you have understood the interest of local orientation. Just a detail about the hand. The hand, even if it is not actually able to rotate around all axes at the same time, neither rotate on 360 degrees, we can say that for a hand, well, it is fine. We can use all the axes at the same time with global orientation. That's not too much of a problem. but it's better to get used to switch to local orientation. It allows us to do things in order. For example, I start by putting the hand straight with Z. With Y-axis, I orient the hand this way, and then with Z-axis again, I can say hello this way. So, that's it about axis orientation. Thank you for watching this video, and I'll see you very soon.